Hello everyone, and welcome back to another video. I teased this motherboard already. This is my new MSI B550 Unify-X, and this is the basically new go-to bench motherboard because, well, I got a 5800X3D, which means my old 5800X non-3D now lives on this motherboard in the test bench. And well, this is just faster than the 8700K. This motherboard's more capable than the Maximus 9 Apex. So this is just better than my 8700K in a general sense. However, Windows 7 on Ryzen, it can be done, but the 260 OST challenge is still a thing, and I'm planning to do some more scores, and I've just been told repeatedly to just don't bother using anything newer than Coffee Lake, so the Z390 Aorus Master and the 8700K are set up right now, which means this is currently not used. However, I will probably go straight back to it once the comp is over. Because I'm probably gonna do some 28nm GPU stuff, and yeah. But anyway, so this is the newest motherboard edition, and yeah, as you can already see by the fact that it only has 2 DIMM slots, this is yet another extreme overclocking focused motherboard. So yeah, this even has my really good B-die in it, because Tropics, which is what we're using for the 260 OST challenge, does not care about your CPU performance really at all, so I didn't even bother putting the good RAM in it. But yeah, so that's just this. And yeah, we're not gonna take the CPU out, it also still has the water block mounting on it. But yeah, so this is the B550 Unify-X. So this is basically a regular B550 Unify, except that 2 of the RAM slots have been removed, so you only have 2 slots instead of 4, which, if you didn't know, helps drastically with memory overclocking. Your maximum frequency goes way up if you have less slots, because there's less signal interference, and your traces also just get shorter because there's less distance to go, because you can have your second slot much closer. So yeah, this is good for memory overclocking, and other than that, this is, I think, just a regular Unify. I'm not actually sure, because the VRM on this is a beast. Is this VRM better than the Aorus Master? This is this and the B550 Aorus Master were the first real 14-phase motherboards. So yeah, this is a 14-phase VRM using the XDPE 13 GSC controller or whatever, whereas previously everything was basically using an IR35201 or something like that, which only gave you 8 phases. So yeah, yeah, we're gonna take a look at the VRM of this thing. I will have to figure out how to remove the VRM and heatsink of this. I have never taken this off before, so it's gonna be a bit interesting. I'm thinking I'm just gonna go talk about general features of the board first, and then try to stumble my way into removing the VRM heatsink. So, we already went into the 2 DIMM slots, just way better memory overclocking because of that. This has a really just super strong memory topology, that paired with the Ryzen 5000 series memory controller, which is just really strong. So this board is this is the board where my first 5 GHz RAM validation is gonna happen. It's basically just a question of throwing in some 4 gigabit E-die and just spending enough time on it. But yeah, so let's just begin with our features. So we get 2 8-pin power connectors. These are the folded pin variants, so these are not the solid pins, which means these can't carry quite as much power per pin. So having the 2 8-pins, if you want to put a 5950X into this, Probably not too bad of an idea to have this if you want to do LN2 on the CPU. However, for my regular 5800X, that's not needed. I don't think even for LN2, I think 1/8 pin is just fine for that CPU. So, you know, it's a nice to have, but not needed unless you want a 5950X with LN2. Then we have a postcode over here. This postcode also doubles as a CPU temperature sensor once you're booted into Windows, which is interesting. Like, I mean, the postcode usually just doesn't do anything once you're posted, so you might as well use it for temperature readout, which is actually quite useful for like seeing like what are certain benchmarks doing right now when you have it in like full screen and can't look at hardware info. So yeah, you have this. You do get a Corsair RGB header, which is like an MSI thing. They have like a partnership. So yeah, you get some debug LEDs. So kinda redundant because you have the postcode, but like one of these will light up if you know, whatever corresponding component is like posting right now. If you have like, if you get stuck, the LED is gonna tell you like what problem you have. It's like a boot, graphics card, RAM, or CPU issue. You do get USB 3.1. The B550 Master does not have this, so if you have like a USB-C front panel on your case, you do want to have one of these or you're not going to use it, like my daily system, which doesn't use it because the Master doesn't have this. You get a power and a reset switch, which is nice for a bench motherboard always, like, yeah, just nice to have. You get this, this switch, which is not a BIOS switch. This board only has one BIOS chip, like the BIOS chip's right here. This is actually an RGB on-off switch. Only that this board doesn't have any RGB. Well, not onboard RGB. You have RGB headers, but like this, like usually you have like RGB somewhere on the board itself, and the switch is supposed to, like, it just turns that off. What this actually does is just disable the always red LEDs on the power and reset switch. This is all it does. It's like you'd have this on, you get red LEDs for these buttons, you turn this off, the red LED disappears. That's all the switch does, which is kind of hilarious. But yeah, you get a bunch more fan connectors and more RGB. You get this 6-pin, which I don't really get why it exists. Like, so the reason why you sometimes get like an extra 6-pin or Molex on some overclocking focused motherboards is when you run dual GPU, specifically 3 or 4 cards on one motherboard, you end up drawing quite a lot of power from the PCI Express slot because it's 75 watts per card. If you run 4 cards, like that's 300 watts just from your PCI Express slot, and the only way how power goes to your PCI Express slot is through the 24 pin, which doesn't have that many 12 volt pins. So for boards that you may very well use for drawing a lot of power from the PCI Express slot, you usually have these connectors there, which are just for extra 12 volts for your PCI Express slot. The problem with this board being that, well, you only have one X16 slot. That's a 4X slot from the chipset. That doesn't do SLI. Like, it does crossfire, but like, also if you put a card in this, that blocks that blocks the power connector. So this is like pretty pointless, because the only way how you could use this is if you either have a riser or just only use the top slot, in which case the 24 pin is just fine and you don't need this. So, I mean, like, A for effort, but I don't think there's any practical use case where you're ever gonna need to use this. Over here you also have a clear CMOS jumper, so you can like wire up a button to this and then just have it be a clear CMOS. You also just have a physical clear CMOS on the back here, so like you can also just press this. You also have a BIOS flashback button, so the board can update the BIOS without having a CPU installed in it. Speaking of the rear I/O, you don't get that many USB ports on this. Like, you could have just have like a 4 port here, or like a third one here, which, you know, It's not that many USB ports, especially compared to the Master, because the Master has like a lot. And it's like how many Type A ports is this? 1, 2, 3, 4, 5, 6, 7. And the Master has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so the Master has quite a lot more. You do get a USB Type-C, you get an HDMI, so this board you can use with iGPUs, you get Wi-Fi 6, and you get a PS2 because Windows XP. If you want to get this running on Ryzen, that is. And yeah, like as for the back, not really anything. You get this little bit of metal for like your, yeah, just like your VRM, which there's a thermal pad there. It's like not a lot of metal, and it's not like the VRM needs any cooling in the first place. So this is kind of pointless, but also like it doesn't hurt anything. So it's just like, okay, I guess. Yeah. And then of course, like the very last feature is just like you get a ton of M.2 slots. Like even more than the Master. The Master has 3 of them. This has 4. So the top slot right here should be straight from the CPU. So you can use an M.2 here, and it's not gonna do anything to the rest of your PCI Express. But if you use, I'm not sure which one specifically, but 2 of these take lanes from your 16X slot, and then the last one should probably just be off the chipset. So I'm just gonna assume that this is from the chipset, and these 2 are gonna be using bandwidth from your 16X slot, because yeah, that's just how it is. Like you can only use 2 M.2s with this, I think. If you use more than 2, you're gonna get 8x on your PCI Express slot here, because the other 8 lanes go to the M.2s. Which, yeah, don't do that with a bench motherboard. You do want your 16 lanes. Yeah. That's just kind of a thing with B550, is like, this doesn't do SLI, because, people want M.2s. So you don't get SLI on this. Yeah, like instead of a second X8 slot, you just get 2 M.2s basically, which is kind of a shame, because I have a B550 Master, which has the exact same problem. I can't run more than 1 M.2 unless I want my 2080 Ti to run at 8 lanes. So but it's not like any motherboard I've had before where I could have used more than 1 M.2, I never did. So I'm just gonna go with like, I'm probably gonna be fine with just 2 M.2s, and I would have much preferred if there was just like a second slot that, would have done SLI, because like, it's a bench motherboard. This is made for extreme overclocking. It would be kind of cool if it supported SLI. In that case, this would also have a reason to, exist. But yeah. Like there's an X570 Unify-X as well. That might do SLI, but it's more expensive, and also it's X570, which means you don't get as much BCLK headroom. Like the thing is, the X570 chipset is a lot worse at BCLK overclocking than B550, just because the PCI Express 4.0 stuff that it has, I think. So if you actually want the best overclocking, like especially for RAM, you actually like kind of have to go B550. Because on X570 you can't raise your BCLK enough to really, have it be an actual benefit. So yeah, that and this is cheaper, and like, like if I ever want to do SLI, I have the Z390 Master. I don't really run that much SLI, so it's not that big of an issue that like my main board doesn't do it. I can just swap in the backup board and then do SLI with that. So it's not too big of an issue. It's just like, I'm never gonna use these M.2 slots anyway, so they might as well have been a PCI Express slot, if you ask me. And yeah, so that's basically it. So let's try to remove this VRM heatsink. I guess let's just go to the back and unscrew all of this. And then just find out as we go what we all need to do to see the VRM. Well, that screw does not want to come out. Is it not fully out yet? No, it is. Is it like... Oh, no. I'm just bad at grabbing it. I've also actually never removed the VRM heatsink from my B550 Master, so... Okay, yeah, like just a bit of thermal pad for your backside of your VRM. Is that enough to just like remove the heatsink? It might actually be. But like I think there's like screws on the side here that I think should also have to go because yeah, because there's like you'll see it once I get rid of it. But I think I have to remove these screws too. There's two more here. And then maybe that might already be enough to get rid of the VRM heatsink. Yeah. Like this part is off now. What about the other part here? Oh, yep. Yes. Okay, yeah, so that's the VRM heatsink. That thermal pad didn't quite come off. But yeah, like that is a very big VRM heatsink. Like you get a heat pipe, and that's a lot of surface area in there. It's a very heavy piece of metal, like all of this is metal. And you also get your, like you're even using the inductors for surface area, like very, oh, it's like the kind of thermal pad that rips. So we're just gonna leave this on. Yeah, so very nice VRM. Like that's kind of what this thing is known for. It's a 14 phase. So we have the controller right here. It's an Infineon. Yeah, like actually what's the actual part number? Yeah, XDPE 132G5D actually. It reports it as like a GSC in software for some reason. But yeah, like that's the like 14 phase VRM controller, and then we have power stages, which I'm not TDA 21490. I'm entirely sure. These are either 70 or 90 amp. I think these are 90 amp power stages, and then it should be like. Is it like a 14 plus 2? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, and then we have 2 extra. Because, yeah, actually this controller is a 16 phase. Yeah, this is actually 16 phases, so 14 V-core and then 2 SLC. You can also tell that just because there's just no other controller here. Like, just nothing here. Yeah, so... You know, VRM-wise, I could actually use the board like this, and it would be fine, because like this CPU, the most I've seen it pull was like 170 watts in like LIN pack with like PBO, everything, every limit removed, and then also the RAM dialed in, because like, you know, if you have faster RAM, your CPU actually starts pulling more power because there's more data arriving at the cores, meaning it can do more work. But yeah, like I've only seen like 170 watts from this, so that's not a whole lot of power per phase. Like, yeah, and those 170 watts were at like not like what voltage? like 1.15 to 1.2 volts, I think. So it's like even less amps, and like on paper, if you have enough cooling, you could manage to do that on like 2 of these phases. You shouldn't do it because you would very quickly overheat the power stages, but you know, technically they are electrically capable of doing it for a short amount of time with like perfect cooling. But yeah, so we have 14 phases. Like even with the 5950X, this VRM would work just fine, like completely naked, basically. Yeah, like you know, B550, like X570, actually Z390 is like where VRMs got a lot better. Yeah, like Haswell kind of ruined VRMs because like those CPUs had a fully integrated voltage regulator. So your vCore VRM actually didn't have to be anywhere near as powerful, because like they had like 1.8 volts VCC in, and then that would become actual vCore inside the CPU. So yeah, a lot higher voltage means a lot lower current, means your VRM doesn't have to be anywhere near as capable. And then VRMs just kind of remained really bad until the 8700K came around, because that CPU started pulling enough power that VRMs actually had to get better, or, well, they will blow up. And that needed a bit of time. Like Z390 has very nice VRMs already. But then X570 is like where it got really, really noticeable, where we got like VRMs like this, where it's just like, this is complete overkill. You could run this VRM completely naked and it would be fine. Which is honestly how a VRM should be built, because you never know like how bad the airflow in a case might be. Like with zero airflow, even this heatsink is eventually gonna like stop working effectively. Because like, yeah, I mean, the surface area is probably high enough to just like passively like exchange heat, but like it's not gonna be very effective with no airflow. So yeah, like VRMs should always be overkill in my opinion, because dumb users exist and there's a lot of them. But yeah, so like it's a very nice VRM. It's not gonna have a problem powering any CPU you can stick in this, and it's certainly not gonna have a problem powering my 5800X, which is literally only half of what you could put in this. And yeah, so it's a very nice board. I'm happy to have it. It, like, honestly, it's like the main problem with Ryzen that I have is that you just can't have safe boot on Ryzen, because that's just how AMD's microcode works. But yeah, like the BIOS on this board is very, very good. Like, yeah, like MSI and Gigabyte, like the new Gigabyte BIOS are like my favorite BIOSes. The old Gigabyte BIOS is probably because there's some things about it that are just like weird or non-intuitive. Kind of same goes for ASRock. Like it's a BIOS that you can work with, you just kind of need to know how. And then all the way at the bottom is Asus BIOS, because Asus BIOS just doesn't make any goddamn sense. Is like my ranking. But like MSI, overall I think MSI is the better BIOS, because like the thing is, you can take this board and like a MSI like Z77 board from like 2011, 2012, when it came out, like almost a decade of time between those two boards, and the BIOS on both of these boards is gonna work exactly the same. Like basically the first UEFI BIOS that MSI ever made works in the exact same way that the BIOS on this board works, because they designed it once and it was really good and they've just stuck with it. Whereas like everyone else just kind of like from generation to generation, they just kind of like changed how their BIOS worked. Whereas MSI just figured it out day one, and yeah, it's just very consistent. Like if you ever had an MSI board, you know how to work with this BIOS, which is great. And also their overall design is just really good. Like, Yeah, because like with Gigabyte, sometimes you have a thing where like you tell it to do something, but then it does something else because of like some setting that you missed somewhere. This board haven't had an experience like that, like at all. It's either gonna work, or it's just not gonna post. Those are the two things that can happen when you change something in the BIOS. Like if it posts, it just works. And with not, well, you hit the CMOS clear button, and then you load back in. Like on Ryzen, you just need to remember to like save profiles, because SafeBoot doesn't work on Ryzen, and the auto recovery is not to be relied on. That's not MSI's fault. That's AMD's fault. Like AMD's auto recovery is just kind of bad. So yeah, just like save profiles, and be prepared to clear CMOS when you have problems posting. And then one last thing, which I don't really know how big of a problem that is. I hope it's not going to happen to me. Is like, so this board has a reputation for sometimes randomly dying. I don't know how likely it is that will ever happen to you. It hasn't stopped me from buying the board. Because warranties exist, and if it just randomly dies, then, well, it's not gonna be my fault. I do a lot of stuff to motherboards. And so far the only one I killed by literally washing it with water and forgetting to take up the CMOS battery. That's what I need to do to kill a motherboard. And actually I'm not entirely sure if that board's actually dead. It's just I tried posting it once and it didn't immediately work. But yeah, some people have said that this board sometimes just randomly dies overnight. I don't know how prevalent of an issue that is. And second issue with this is this board likes to delete your BIOS profiles. It has happened to me already. And this is sort of half intended, but also not really intended. Because your BIOS profiles on this just disappear sometimes. You can save profiles to a USB stick, which is what I would just recommend you do instead. But the BIOS profiles on this disappear sometimes if you change your CPU or your RAM. And it has happened to me when I changed the RAM. They were just gone. And when you put the old hardware back in, they're supposed to come back. But that hasn't happened to me. They stayed deleted. So yeah, if you want to make sure, just save your profiles to a USB stick, then you'll always have them. But that's the one actual BIOS issue with this is the profiles disappear, which is half intended, because it's for supposed to save them for different hardware configurations. But if they don't come back, if you put the other hardware back in, then doesn't work correctly, does it? Also, it makes it really annoying to test different RAM kits, because what if you just have a profile of if it can post these settings, if you bin BDI, and you just if it posts these settings and it's stable, then it's good BDI, and you put in a different RAM kit and then the profile is just gone. Yeah. Again, not really an issue that I think is a thing that you shouldn't buy this board for, because also you don't really have a choice, because it's the only purpose-built extreme overclocking 2 dimmer on AM4. Really. There's the X570 Unify-X, but again, X570 has BCLK issues. And then all the other 2 dimmers on AM4 are ITX boards, which are not purpose-built for extreme overclocking. This one is. So yeah. Anyway, I think that's gonna be it with the overview of the MSI B550 Unify-X. From the amount of testing I did with this, I already had a lot of fun with this board. It is a very reliable motherboard, as MSI usually is. MSI is overall, Gigabyte's my favorite motherboard brand, but MSI is very, very close behind, because MSI just, if you buy an MSI board, it's just gonna work. It might not be the best at overclocking. If this wasn't a 2 dimmer, it would lose to the Gigabyte topology, because they just have the best AM4 memory overclocking topology for anything that's not a 2 dimmer. But like if you buy an MSI board, it's just gonna work. They're just reliable because they're just so consistently good with like their BIOS. Whereas everything else is like just not as consistent, or like changes how their BIOS works and stuff. So like, yeah, like my recommendation for like, I just want a motherboard where I can, you know, it's just gonna work. I just like get an MSI one. If you want peak performance on AM4, probably Gigabyte, or this one if you want 1 DIMM per channel specifically. But you know, MSI is always like the safe pick. So like I don't think you ever make a mistake by getting like an MSI board, unless it's like a very, very cheap one. Because like very, very cheap motherboards are, well, very, very cheap motherboards, and you probably shouldn't get the very, very cheap ones. Not that you shouldn't get cheap boards in general, just like avoid the super, like the most bad bottom tier ones, because they tend to suck, because there's only so cheap you can make your motherboard before you actually start removing very important things. But anyway, that's gonna be it with this video. So yeah, if you're still here, thank you for watching, and until next time, goodbye.